All right, so today we're going to look at finding missing angles. So chances are, unless you're watching these out of order, everything we've done so far has been finding missing sides. The good news is what we're doing doesn't really change at all. It's actually going to be at least one or two less steps. So we're really going to have the same steps of label the triangle. Okay. Decide trig ratio. So which trig ratio? Set up the problem. And really solve the problem. Okay. So we'll look at a few examples here. Let's say this is my right angle. Now this time we're not going to know the angle. So I might just put an X there. Let's say we know this is 40 and this is 32. Now, think about that for a second. Why can't that be accurate? That's right, because the hypotenuse has to be the longest side. It can't be shorter than any of the other sides. So let's call that 68. Okay, so what this means is we have three values, just like we did with finding missing side, and one unknown. It just so happens that our unknown right now is an angle. But we're going to start, there's the right angle, so across from that is hypotenuse. Okay, there's our reference angle, even if we don't know what it is. So across from that would be opposite, and what's left over is adjacent. So the two sides that I care about are adjacent and hypotenuse. So if I remember TOA, that's going to be cosine. So I come down and I know cosine. Now, we always said cosine of the angle. That was always a number. This time it's not. It's our variable. So cosine of x, and it's adjacent over hypotenuse. Now, remember going back to like algebra. If you had an equation, I'm going to write it in red right here. Let's say 2x equals 8. And to solve that, you would divide by 2, right? Why do you divide by 2? Because it's the inverse of multiplying by 2. So to get rid of this cosine, and I'm going to write it out longhand right now, but it won't, I'll shorten it after a while. We do something called the cosine inverse. Okay? Now what happens on one side has to happen on the other side, right? So we do it on both sides. When we do it on the left side here, these, and I know I'm using a lot of colors here to hopefully keep it straight, but these actually cancel out. So I'm just left with x. Now on this side, that's all going to go into our calculator. Now for most of you, and every calculator is a little different, there may be an inverse button. A lot of times it's the second button in the calculator. You hit second, and then cosine, because it's a cosine inverse, and you just type in 40 divided by 68 in parentheses if you have them. And I get 53.96 degrees. So we're going to round that up to 54 degrees. So we'll still round to one decimal, okay, but this one just happened to round up to a nice number. All right, so let's look at one more example on this video. Let's say here's my right triangle. Let's say there's my missing one. This is 20, this is 27, okay? So start, there's my right angle, so this would be the hypotenuse. Reference angle, so there's opposite. What's left over is adjacent. So the two things we care about are opposite and adjacent. O and A are tangent, so I'm going to say the tangent of my angle, which is y, equals opposite, 27, over adjacent, which is 20. Okay. To get rid of the tangent, I need to do tan inverse on both sides. They'll cancel out, so basically y is going to equal whatever the tan inverse of 27 over 20 is. So I go to my calculator, I hit second tangent, 27 divided by 20, and I get 53.5 degrees. So that would be my answer. So really the same setup, just getting used to using inverse trig ratios.